Hello and welcome back to the lesson 3 in the module 7. We were dealing with rational functions. Now we will talk about graphing reciprocal functions. The learning objectives of this lesson are to graph reciprocal functions by making table of values, and graph and write reciprocal functions by using transformations. This is a very useful method as well. Now the keywords are reciprocal function, vertical asymptote, horizontal asymptote, hyperbola, excluded values. We will come across all these words as we move along the lesson. Now the first thing is reciprocal function. What is this exactly? Now you can see over here, it has been told you will see the graph in a while if you have a function, say 1 by x or 1 by 3x minus 1, 1 by 2x. What can you observe over here? There is a constant value. The numerator can be anything. It can be 2, 5, 6, anything. But the denominator is the function. It should be a linear function. Everything is to the power 1 here. Linear function. So when the denominator is the linear function and the numerator is a constant number, we get reciprocal functions. Reciprocal of x, the inverse, like 1 by x, okay? So something like that. You need to remember this. We will have the linear function in the denominator, as you can see over here, and a constant in the above. And this will cause few problems. Why? Because you can't divide 1 by 0. What is 1 divided by 0? It's undefined, right? It cannot be defined exactly. So this would cause into excluded values or certain things that can't be included in the graph. So anything that is having a denominator 0 is excluded. So if it's 1 by x, you see the x value can't be 0, so the graph can't be in any of this region. So it'll be something like this and like this. Okay, we will have asymptotes, horizontal and vertical asymptotes. We will see them now. This is the reciprocal graph, as you can see over here. 1 by x. Now since x can't be 0 here, you can see there is no graph here, and there is another horizontal asymptote. Before that, we need to realize what the graph is. This graph, you can see a part over here and part over here, is called hyperbola, the name of the graph. Okay, and all non-zero real numbers. See, this is very important. It can be any value. X can be any value. You will have a point in the graph, but it's all non-zero because it can't be 0. And over here, the asymptotes are when x is equal to 0 and y is equal to 0. See, these are the asymptotes. And then when x is 0, it's not defined. And over here, there is no intercepts because none of the, in this case, it doesn't have any intercept. Why? Because if you put over here any intercept 0 over here, it wouldn't be defined, right? So that's why. Now then, what we will do is we will see some problems, how to solve them. You need to determine the excluded value for x for each of these functions. Now, excluded value is very, very simple. Whatever is the denominator, the function in the denominator must be equated to 0. So this is x equal to 0. What is the value? It's 0 itself. So other than 0, you can have any value in the denominator. You can have 1, 2, 3 or negative, any values other than 0. So excluded value is 0 because it's undefined at 0. Now what about this? Whatever is the denominator, x minus 7 is equal to 0. So solve this up, it will be x equals 7, and this is the excluded value. X is equal to 7. So 7 is the excluded value because the function is undefined at 7. Only at 7 it's undefined, all the other values it's fine. And what about this? Here the denominator 3x plus 4 equals 0. So now we can simplify this. 4 goes to the other side and becomes minus 4, sorry. And divide both the sides by 3. It will be negative 4 by 3 or negative 1.333. So negative 4 by 3 is the undefined value over here. That's the excluded value. All the undefined points must be excluded because you can't have that. If you put over here negative 4 by 3, then the denominator is 0, so the graph will be undefined. The function will be undefined. Please do pause the video and try these by yourselves. These are very straightforward problems. Let's do the first one here. 17x equals 0. 0 divided by 17 is 0, so x is 0. Here it will be 11, and over here it will be minus 8 by 2 is minus 4. So these are the answers. Sorry, 0, 11 and minus 4. So they are the answers over here. Now then, we will move to the second type of problem where we are being asked to graph using a table method. Table method is one of the most basic method to graph because you can graph anything by table method. Now here they have given a graph 1 by 2x minus 5 plus 2. We need to graph this out. So first of all, let's identify, they have asked to identify the key features. Now, what are the key features? Basically the asymptotes, the excluded value, all those, okay? First, let's see the denominator. Let's equate it to 0 and find what is the excluded value. The excluded value is 5 by 2. How? Over here 2x minus 5 equals 0. So 5 goes to the other side, it will be 2x equals 5. X equals 5 by 2 or 2.5. Now, what does this excluded value mean? There it is the vertical asymptote. You will have a vertical asymptote over there. If that is the point 2.5, the graphs cannot touch there. They'll go there down towards infinity, but it'll go very close to the asymptote but does not touch this asymptote. So the same thing over here, it will be something like this at 2.5. Now that is the excluded value and the vertical asymptote. Now you can see the function over here is of the form what? N by the function, linear function b of x, plus there is some value k. So k is 2. So where is the horizontal asymptote? Now initially it will be something like this, right? Now whatever is this plus value will make the function jump just like any other function, like a linear function. If you add something here, it will jump. So now instead of this becoming your horizontal asymptote, it's jumped to 2. So over here will be the graph changes, it's something like this. Okay, it shifts up. We will see the graph in a while. Now so this is the horizontal asymptote, and you can see this is the thing. So what are these two things? The domain over here, the x value, right? Domain can be any possible value except the excluded value. So x is all real numbers but not equal to 5 by 2. Same way, the range, the y values can be any, but at positive 2 there is a horizontal asymptote. So it can be any value. This function g of x or y can be any real number but not equal to 2. That is what it means. And the horizontal asymptote is at 2. Now graph the function and identify the intercepts. How would you do this? So here, graphing the horizontal and the vertical asymptotes with dashed lines, and then using the table of values. See, you're making a table of values. That's what they have asked over in the question as well, table of values. You can make these points, different points, and graph it out. Now, how would you take the points is one concern, right? So see, where is your horizontal asymptote? We know it's at 2.5, isn't it? So take values before 2.5 and after 2.5. 2.5 is somewhere over here. So before that and after that. So evenly distribute the points, and we have got some points. Just how do you find these points? You have the equation, right? Here, instead of x, just change the values. Put 1 and solve. You will get, when you put x as 1, you'll get 1.67. We have done this graphing many times before, so I'm just going through this. So same way, put over here 4, change in the equation, wherever x is there, put this 4, and you will get different values. And this is how you get these points. Okay, then you just draw a smooth curve. But before that, this is the graph. Now you can see it was plus 2, so the asymptote here shifted to 2, and the vertical, we solved whatever was in the denominator function, and we got x of 2.5 excluded value, and we get this. So that's very, very important, the asymptotes. And now this is simple to draw, make a table. Now there's something else. They have asked the the intercepts. For x-intercept, always the y value is 0. If you want to find the x-intercept, substitute y equals 0. That means the function is 0. Now this is the given function, right? Here all you need to do is to find the x-intercept. X as it is, g of x is 0. That equals 1 by 2x minus 5 plus 2. You can put this in the calculator directly and solve as well. You will get the answer. But now I'll solve it. 2 goes to the other side, will be minus 2 equals 1 by 2x minus 5. Now take this to the other side and it'll be negative 2 times 2x minus 5 equals 1. It'll be minus 4x plus 10 equals 1. Swap this 1 to the other side and minus 4x to the other side. It'll become 10 minus 1 equals positive 4x. 9 equals 4x, or x equals 9 by 4, that is 2.25. The answer is 2.25 x-intercept. Now you can see over here, if you solve, you get x of 2.25. That is the x-intercept. Now what about the y-intercept? Same thing. For y-intercept, only thing is x is equal to 0. Now here, g of x means y equals 1 by 2 into 0 minus 5 plus 2. Here this is 0. So that is basically 1 by 5 negative plus 2. So this is negative 0.2 plus 2. That's positive 1.8. You're subtracting 2 from 2 minus 1, 0.2. It will be 1.8. That's the answer. Positive 1.8 and positive 2.25. These are the x-intercept and y-intercept intercept respectively. If you want to find x-intercept, put y as 0, whereas if you want to find y-intercept, put x value as 0 and then solve. So this is how we can graph any function. Now here they have asked you to find few of the important characteristics. Now where is vertical asymptote? Whatever is in the denominator, x, make it equal to 0. So here it's directly 0. Easy. And what's the domain? Domain can be any real numbers, but exclude this value. That is the asymptote value. Now what about the horizontal asymptote? X-intercept. Wherever you have g of x, just put 0. This y value is 0 equals 3 by x plus 1. 1 goes to the other side. Minus 1 equals 3 by x. X goes to the other side, minus x equals 3. Take this, swap the signs, it'll be x equals minus 3. So the intercept is at minus 3. So it's 0, 0, minus 3 here. And the same thing with the horizontal side. How do we do this? Horizontal asymptote is whatever is added. That's 1 here, and that must be excluded in the range. And now the intercept, make x of 0. But look over here. Can you make this 0? Now x value is 0, right? Can you make it 0? It's undefined here, right? So there is no y-intercept. It's undefined, none over here. Or there is no null, empty symbol or none. Okay? Sometimes you can write it like this as well. This is empty set. That means there is no y-intercept. That's the answers. Now here we have got a real world problem. Ohm's law states that electric circuit operates according to the equation I equals V by R, where I is the electric current in amperes and V is the electromotive force in volts and R is the resistance of the circuit in ohm. Now analyze the electric current of 110 volts curling iron in relation to the resistance of its circuit. Write and graph a function. Now here you have been given this equation I is equal to V by R, and they have given voltage, that is V value is given. These two are unknowns. It's basically like Y equals 110 divided by X. So there are two variables, right? That's the function. So you're getting this I equals 110 by R. You can write it as Y equals 110 by X, whichever. Now what is the undefined value? This is XR equals 0, right? So the vertical asymptote is over here. Now what is the horizontal asymptote? Is there anything added over here? Is there anything added? Plus nothing, it's 0. So the horizontal asymptote is 0. So these are two things. Whatever is added is relation to y, isn't it? Now here we have r instead of xr instead of yi. So I is equal to 0 for horizontal asymptote, r equals 0 for vertical asymptote. If you're getting this confused, write y equals 110 by x. Now x equals 0 is the horizontal asymptote, there is nothing added, so y equals 0 is the vertical asymptote. And then you can make a table of values and draw a smooth curve. Now over here, which are the values you should consider? Some values before 0 and after 0. So these are few of the values, and just draw a smooth curve. This is very straightforward. All you need to do is, whenever you consider these values, now it's taken in terms of tens because it's easy to calculate. Now imagine if it's 10, substitute 110 by 10, r changes to 10 because that's our value. It's 11. So at r equals 10, the value over here is 11. This is 20. So this is somewhere about 11. Same way you need to plot the other points. When it's 20, it's 5.5, 30, it's 3.75, and negative values correspond accordingly. Now we need to analyze the key features. We have done this already. So we have the domain. It's already there in the previous page. It was there over here. That's the vertical asymptote domain. So it should not belong to 0. R can't be equal to 0. I can't be equal to 0. That's the range. Intercepts. What do you do over here for intercept? Put the x value as 0. Can you put it as 0? R? No. Put I value of 0. I? No. Why? Because this goes to the other side. It's interchangeable, and it's no. There is no intercepts. None. Why? Because it will be undefined if you try to find the intercepts. And when is it positive? Now, whenever I is greater, it's positive. When I is less, it's negative. Now, what does that mean? Basically, you can see over here, positive in the sense, this is the positive graph over here. Okay, when we have a positive function, in the sense there's a number which is positive over here, whenever y is greater than 0, it's positive, y is less than 0, it's negative. But if this is minus, then this changes. Okay, so that's basic. It's basic graphing, you know, we have done similar things before. It's just a similar thing. And symmetry, so you can see it's symmetrical about the origin. It's same, looking same. Symmetry means it's similar, like a butterfly, you know. So that's what it means. And symmetrical about the origin. And what is the end behavior? End behavior of the graph over here. What is happening as the x values increases over here? What happens to the y? As x value increases, as x goes to infinity, y is going towards 0. So that is what we need to write. See, as r is going to infinity, I is 0. Whereas r was going to minus infinity, again I was going to 0, right? Minus infinity is here. So it was something like this and like this. So when you go to minus infinity also, it goes to 0, and infinity also is going to 0. So end behavior. So these are a few of the things. So generally they'll ask what is required. No need of everything, but it's just good to know. Now over here, similar problem. These are very important: x-intercept, y-intercept, domain range, and the asymptotes. So over here they have asked, a group of friends plans to rent a cabin at Red Pine Ski Lodge. The cabin costs $750 to rent for the weekend. Let x be the number of friends who are sharing the cost, and y be the cost of each person. Graph a function representing the average cost per person to rent the cabin. Analyze the key features of the graph. Now, if you see this properly, now y is the cost for one person. But what is this equal to? Now, it depends on the rent divided by number of people, right? See, x is number of people, x be the number of friends. So if there are 10 friends, x is 10, and for one person, y, it will be 75. So what we can do is, we don't know the number of people, so we'll write it as x divided by x. So 750 divided by x. So as the number of people increases, you can see the cost will reduce. It's a reciprocal function. Now what's the domain? This equals to 0. Here x is 0. What's the range? Nothing is added. 0. What's in x-intercept? Can there be x-intercept in such case? When you make any of this 0, it's undefined. So none. No x-intercept, no y-intercept. Whenever we have these two 0, the asymptotes are 0 and 0, the intercepts cannot touch this. Now what next? Where is it positive? Now first let's see the graph over here. You can see the positive is this positive side. Whenever x is greater than 0, you can see x is greater than 0. What's the graph is positive? It's in the positive quadrant. Whereas it's less over here, it's in the negative quadrant. But when the sign changes, this goes to the other side and this, then you can say now whatever is drawn in black is the graph over here. As x is greater than 0, it's negative over here, okay, because this is down. But in this case, you can see as x is greater than 0, it's positive, so it should be great. Okay, this is not equal to 0, 0, none, none, and it's greater than 0, it is positive, whereas if it's less than 0, it's negative. What about the end behaviors? As x is tending towards negative infinity, left side, what happens? Y value, y axis, it's going towards 0. And same thing over here, as it goes to x positive, y value is 0. And given the context over here, given the context of the situation, the domain is limited to what? See, x value, it is y equals 750 divided by x, right? X is number of people. Can there be negative people? Can this happen? No, it can only be positive. So only positive integers are possible here. And you can't even have real numbers. Why? Because you can't have 2.5 person, 3.5 person, 7.5 person. You can have only 1, 2, 3, 4. So integers, positive integers. Integers are 1, 2, 3, 4, 5 and so on. So that is the thing. So that's about graphing simple reciprocal functions. Now transformation of reciprocal functions, the last part. Now same techniques of graph. So if you're going to use the table method, you can use that everywhere. You will get the same answer, no problem at all. But now here there are a few things. What I'll do is I'll be putting a link for the transformation of graphs in the comments, not in the comments, in the description of this video. Please do click on that video. It's transformation of linear functions, but it's much similar to this. You will get a very basic understanding and good idea about how exactly these all terms work, because that video is already there. So please do click on that video and watch it. It is for linear functions. You can forward it and go to the part which you want and watch it. It's for linear functions, but it is relatable. Okay, so here I'll just tell you a few basic things. This one, if it's a graph like this, sorry, let me draw a proper one over here. Now if it's something like this, the reciprocal function, this k, if it is phi, what happens is this asymptote shifts over there to phi and over here phi. Okay, here since it's minus, now imagine this is plus, since it's minus, what happens is, imagine you have 1 by x minus 2. If it's minus, this over here moves to the right side basically, because the minus is already there. H value is only positive 2, right? It moves to the right side. Now what happens here, instead of 0 and 0, see, instead of like this, this moves to the right by 2 units. So here you can see it should move something like this. At 2, that will be the vertical asymptote. Okay, whatever is k will shift the horizontal asymptote, whatever is h will move the vertical asymptote. If it is plus 2, then it goes to the left side. So what happens is, if it's plus, imagine, always remember it's left, and it will be something like this. Okay, so this is the thing. Now we will see, and what about A? That is the orientation on shape. We will see whether it be stretched vertical or compressed vertically. So please go down and click on the video and watch it, because all these have been explained in detail in that video. What is vertical stretch, what is compression and everything. Okay. So here now we have a graph. Don't worry, it's very simple. Now if you're going to use the table method, you can directly solve it. Now here you can see this is the parent function, in the sense this is the reciprocal function, but instead of this we have all the big one, but it's just transformed. Okay, it's just transformed. Now you can see this is the original function, right? How has it been transformed? Since it's minus 2, now this would have gone down to minus 2, 1, 2. So this would be the asymptote over here, horizontal asymptote over here. You can see that's the asymptote. And since it's plus 1 in the left side, we will have the horizontal asymptote at minus 1. Can you see? So these are very, very important. This and this tells you where the asymptotes are gone. Now minus 4, if you go in the video, you will understand whenever we have minus 4, or sorry, first let's just talk about 4. Whenever we have number greater than 1, x must be greater than 1, sorry, this is considered to be a. So whenever a is greater than 1, you have vertical stretch, in the sense it gets stretched vertically. Whereas if it's less than 1, a is less than 1, it gets compressed, it gets compressed compressed, okay, vertically compressed. So now here you get the asymptotes. Now this negative sign, what it does is it flips these. This is flipped down. So now here it always is reflected along the x-axis. Okay, reflected along x-axis, in the sense, now here if it is 1, 1, it would be over here at 1, minus 1. Y becomes minus. But since all these transformations are there, it is moved to a different place altogether. It moved over here. Now you can see this part is reflected down, and this one is something like this. And the 4 will make it vertically stretch. So minus 4 is reflected along x-axis and stretched vertically, and this h minus 1 is basically the vertical asymptote, this one over here. Whatever is there, you should change the sign opposite, whichever is with x. If it's x plus 1, the h value is minus 1. If it is minus 1 over here, it would have been plus 1 here. And lastly, the k is minus 2, that is the horizontal asymptote. Now for this, all these three things, please go to the link video in the description and you will understand much better. See the domain over here, all you need to do is exclude the vertical asymptote and the horizontal asymptote. For the range, horizontal asymptote. For the domain, it's the vertical asymptote that must be excluded. That's it. Over here you can see, sorry, this graph is already shown. Now here you can see this is 0, 0. Now what happened? It's minus 1, so it is moved 1 to the right, the horizontal asymptote over here. And what about the plus 3? That will make 1, 2, 3. So over here, see, this is the horizontal and this is the vertical. That is the main thing which you need to figure out. And if you want to see which is the correct graph, if you have many options, choose any point in the graph. I'll choose, say, this point. What is it? X value is 0. Substitute x value 0 over here. It's gonna be 1 by minus 1 plus 3. So it's minus 1 plus 3. It's 2. Y value must be 2. Count it. 1, 2. Yes, it is 2. Now, otherwise you can choose any other point. I'll choose this point. 1, 2. X value is 2. So 1 by 2 minus 1. X will be 2 plus 3. Solve it. It will be 1 by 1 plus 3. So it's 4. Let's count. 1, 2, 3, 4. Yes, it's at 4. Y value is 4. So this is how you can easily check the graph. But the asymptotes is very important from here and over here. Now the domain is all real values, but you must exclude what? Positive 1 here. But the horizontal range, this vertical y-axis range, you must exclude positive 3. Okay, that's it. You can write either y and y or g of x. So that's the thing. Now here a graph has been given and you must tell what are these values over here. So this is interesting. Okay, now how would you do it? First of all, see if the horizontal asymptote has been shifted from 0, 0. Yes, it's shifted. Where? To down over here. It's minus 2. So you can see k value is minus 2. Now y value, that is equal to minus 2. What about the x value? It has moved to the left over here, minus 4. So x asymptote is at minus 4. But remember, if you're writing this over here, it'd be plus 4, okay? But in reality, it's moved to minus 4. And so you can see the h and k value over here have been shifted, is equal to minus 4 and minus 2. And what about a value? Now this is very simple. When a graph is given, they have told choose a point, use a point in the graph to solve it. Now you can choose any point. Here they have taken 3 and 3, but you can take any point, but it should be accurate, okay? Now you should, the graph is not so zoomed, and since they have already given the point, better to take that rather than risking any other point. So you can take other points as well, it will be the correct answer, but they have already given this in the graph, okay, in the question. So you need to understand this is x, y. Substitute in this graph. What is g of x? That is y, right? Y value is 3. All I'm doing is substituting over here 3. A is unknown, that is what I'm solving for. What is x? X over here in this case is minus 3. And minus, what is h value? Minus 4 plus, it's minus 2. K is minus 2. I'll directly write minus 2. You can put this in calculator and find a value, or let's solve it. 3 equals a by minus and minus becomes plus. It's plus 4 minus 3. It's 1 minus 2. So minus 2 goes to the other side. It becomes 3 plus 2 equals a. That is equal to 5. A is 5 here. So you can see that's how we solve it. And that's it. Asymptotes give you the a and h value, h and k value. This one over here is the x, minus 2 minus 4, and k is minus 2, and a value. You should just choose the point which is given, or if it's not given, it'll be easily available. The graph is now a little bit complicated because of these different scales. They will give you the point, okay? Just substitute over here x and y, substitute the y value 3 and substitute x value as minus 3, and the h and k value are known. Solve it and you will get the a value of 5. That's how we do it. Now substitute all the values back. It will be 5. This minus h, minus and minus becomes plus, so it will be plus 4 and minus 2. That's the answer. So here the same thing. Let's quickly do it. Now here you can see they have not given any point, so you can choose. Okay, they have given a point over here, 8 and minus 2, but you can choose any other point as well. I'll choose 2 and 0. It'll be the same answer, not to worry. Now let's see the asymptote. Where is it? It is not at 2, it is in the middle of 2 and 0, okay? It's in the middle of 2 and 0, so it is minus 1. So h is minus 1 over here. What is k? K is 2. See, this is the value. K is 2. Just looking at the graph. What is a? I will just substitute and solve. Let me take this 2, 0. And I'll just put over here y is 0. That is equal to a value is unknown. X value is how much? 2 minus of minus 1 plus 2. Now plus 2 goes to the other side, becomes minus 2 equals a by 3. And 3 goes to the other side. A value is minus 6. That's the answer. Let's try it even with this point over here. It's minus 2, 8. Okay, minus 2, 8. Let me just put the values over here. 8 is the y value. So this y value is 8 equals a is unknown divided by minus 2 minus of minus 1 plus 2. So 2 goes to the other side, becomes minus 6 equals a divided by minus 2 plus 1 is minus 1. Minus 1 to the other side, it becomes 6 minus 6 equals a. And you can see it doesn't matter which point you take, the answer is always same. It's minus 6a. So a is minus 6. And you can see the answers minus 6, minus 1 and 2 from here. Now substitute everything here. It will be minus 6 divided by this minus and minus becomes plus. So x plus 1 plus 2. That would be the answer. Very simple problems, and that's it. So this is how we would graph reciprocal functions. So it's very simple. Understand the graph. You can use Desmos to understand the graph better. Anything in the denominator. See, if you have a denominator as a linear function, y equals 1 by this denominator must be anything to do with linear function like this, okay? Plus 3. I'm just given a complicated one, but in simple, you can just write 1 by x. This is a reciprocal function. That's it for this video. If you have any doubts, please do put them in the comment section, and also try to go through the video which I put in the description. That will enhance your understanding about transformation of graphs. Bye bye until the next video. Take care, guys.